Hello, this is video number 3. We're going to be looking at a couple of tricks that we can use with slightly more complex problems to do the normal distribution. The first few problems are pretty straightforward. I don't think you'll have any problems. There's some regular normal problems and some inverse problems. We're going to skip straight down to part I. So here we're saying that no more than 10% of all cars should be under 20 miles per gallon. We're keeping our standard deviation from the start, which was 6, and we want to figure out what the mean has got to change to in order for us to meet this condition of 10% being under 20 miles per gallon. Our calculators we can't just type in the information we know for this. We can't put that information in, so we're going to have to use a bit of a trick in order to do that. So I'm just going to put down the information I know. I know that we've got a normal distribution. We don't know what the mean is, but we do know that the standard deviation is 6. So that's what we're looking at. So here's my mean. I also know this, that the area down here is 0.1, and that corresponds with 20 miles per gallon. So I've got quite a lot of information here, but it's not going to help me find mu in the state it is at the moment. What I'm going to do is think about my standard normal distribution. The advantage with this is that we know that the mean is 0 and the standard deviation is 1. So I'm still looking at the same situation of having 0.1 down here. I don't know what z value this corresponds with, but I can use my inverse normal to find this z value because I've got the area, I've got the mean, I've got the standard deviation. So let's do that quickly here. In fact, I've already done that. So I entered the area, the mean, the standard deviation, and I got this value. So we know the probability that z, big Z, is less than little z is equal to 0.1. So using our calculator we can get little z is 1.28155. I'm going to be using this value later, which is why I've written down a few extra figures here for me. So we know a formula that links to z. It's this idea of calculating how many standard deviations we have. Z is x minus mu over sigma. It's the only formula we get for the normal distribution in our formula guide. So let's put in the values we know. We know z, we know x is 20, we don't know mu, but we do know the standard deviation is 6. So now I've got a linear equation that I can solve for mu. I'm not going to go through how to do that because I trust you're all capable of that. So we end up with mu being 27.7 miles per gallon. Thinking about the context of the question, that does make sense. We're going to have, if we're not changing the standard deviation, we're going to have to increase the fuel efficiency to make our cars more efficient and to have fewer cars that have this low miles per gallon fuel efficiency. So that's how we can solve part I. Part J is a similar idea. So I'm just going to keep some parts of this. What do I want? I want to erase this, I think. And I'm going to erase this. But I'm going to keep this. So in J, the car manufacturers are saying they can't get the average to 27.7. They can only get to 26. We talked about the only two parameters that are controlling our normal distribution. They are the mean and the standard deviation. So if we're saying that the mean can only get to 26, we're going to have to change the standard deviation in order to get to this efficiency. So we still want to have 10% down here below 20 miles per gallon. So this setup's very similar, we just have a new mean. Obviously, all of this information about Z is still the same. We've still got 0.1 as our area, so we're still talking about the same Z score. So now I can use this original Z score from before with my new mean to calculate what our standard deviation has to change to. So that's my Z score. X is 20. We now have mu as 26, and we're looking for sigma. So once again, it's a linear equation where it can rearrange into a linear equation. We can multiply by sigma, divide by our z, and evaluate that so that we will end up with standard deviation of 4.68 miles per gallon. So our standard deviation has decreased. It's gone from 6 to 4.68, showing that there's going to be less variation in the efficiency of our cars.